This is section 6.4, properties of the definite integral. Students will use properties of the definite integral, find the average value of a function, and interpret integrals revolving rectilinear motion. As a reminder, rectilinear motion, we're just dealing with straight line motion. I know in physics you can deal with x and y together, but we're just going to keep them separate for our course. So my first theorem, the integral of the sum of two functions. If two functions f and g are integrable on the closed interval from a to b, then I can integrate each one individually. You don't have to keep them together. You can treat them as two separate small problems. The other thing that's very helpful is the integral of a constant times a function. If a function f is integrable on the closed interval from a to b and k is a constant, then I can take this constant that's inside the integral but in front of the function and now pull it to the outside. We did that with derivatives, we did that with limits, so that can be a helpful thing to know. Example 1, let's integrate each of the following. So this is one where we have a sum and you can find the antiderivative of each one independently. So I would have x to the third over 3. The antiderivative of e to the x is e to the x. Using my fundamental theorem of calculus, I've got 0 and 1. The 1 would go in first, so this is 1 cubed over 3 plus e to the first minus, this would be 0 plus e to the 0. So in the very beginning, this is 1/3 plus e minus e to the 0. This is going to be a 1 minus 1. So 1/3 minus 1, we have e minus 2/3.
Yeah.
There we go. There's our solution. I don't need a decimal equivalent. Again, e is always more precise than having that decimal in there. Good. Letter B. If I have 3 over x dx, I know the antiderivative of 1 over x is going to be natural log. This 3 is a constant that I can pull to the front. So I can think of it as 1 to e, 1 over x dx. Now, if I look at the inside, the antiderivative of 1 over x is natural log of x in the absolute value between 1 and e. So 3 natural log of e minus natural log of 1. A few log rules here to keep track of. Natural log of 1 is equal to 0. Natural log of e becomes a 1. So this is 3 times 1 minus 0. So our answer is going to be 3. Good. Letter C is a little bit different. So in letter C, we don't have something to pull to the front. You could almost think of it as breaking it into separate problems. What we're really going to do is divide each term by that 2x. So that 2x is going to go underneath all of them. So we have from 1 to 2, 3x cubed over 2x minus 6x squared over 2x minus 5x over 2x plus 4 over 2x. And this is a dx problem. So at this point, you want to go through and algebraically simplify each one of these terms. So from 1 to 2, this is 3 over 2x squared minus 3x minus 5 over 2 plus 4 over x dx. So now what we need to do is find the antiderivative of each term. So 3 over 2x cubed over 3 minus 3x squared over 2 minus 5 over 2x. The antiderivative here would be 4 natural log of x between 1 and 2. So we are going to cancel the 3's here. We're going to go through this whole problem and put in the 2 first. So this would be 2 cubed over 2 minus 3 over 2, 2 squared, minus 5 over 2 times 2, plus 4 ln of 2. Do the whole thing again. I've got 1 cubed over 2, minus 3 over 2, this is 1 squared, minus 5 halves times 1, plus 4 ln of 1. So 2 cubed over 2, that's 8 over 2. This is 4. Oh, let's see, what else do we have? 4 over 4, that's 2. This is 6 minus 5 plus 4 ln 2 minus 1/2 minus 3/2 minus 5/2. Natural log of 1 is 0. So for -11. Okay. So sorry, did a little bit of calculating there quickly. I replaced all the x's first with the 2 and then with the 1, combined like terms. -7 plus 7/2 becomes -7/2 because this would be -14/2 plus 7/2 would be -7/2. So there's your solution. Again, I don't want a decimal answer for that. All right, I have another theorem for us. If the function f is integral on an open interval containing the numbers a, b, and c, then the integral from a to b can be broken into the integral from a to c and c to b. I'll draw you a picture of that in a second. But what this always reminds me of is geometry and those segment addition postulates. Okay, I know I have this segment on the left. I have this segment over here on the right. When I add those two together, I get the entire segment. And we did the same thing with angles. You said, all right, this angle up here on the top plus the angle on the bottom. If we add those together, the angle on the top plus the angle on the bottom, if you add those together, you have the angle of the whole thing. So to me, and I'm definitely more of a visual learner, I think of it like that. So with my integrals, if I know I'm discussing area under a curve, if I'm going to go from A to B, and this is telling me, see, I don't love the directions here. I would say that A is less than C, which is less than B. So I know that C is in between. So I can say, all right, the area from A to C plus the area from C to B is going to be the whole area from A to B. So that's all we're saying there, and that makes sense. So for example 2, if f is integrable on the closed interval from 3 to 25. Now this one's very vague. They didn't give us a whole lot of information. We're dealing with the numbers 3, we're dealing with the number 10, and we're dealing with the number 25. So instead of solving this directly, I'm going to set up my own statement up here. I'm going to say the integral from 3 to 10 of f of x dx, and it doesn't matter what the function is equal to, nope, not 3 to 10. Sorry, this should be 3 to 25, the whole distance. Would be equal to the integral from 3 to 10 of f of x dx plus the integral from 10 to 25 of f of x dx. So if I want to solve for this piece, the 3 to 10, which is here, I'm going to subtract that 10 to 25. So the integral of 3 to 25 of f of x dx minus the integral from 10 to 25 of f of x dx is equal to the integral from 3 to 10 of f of x dx. I started it with an addition postulate. It's not really postulate, but with the addition, if it makes more sense to you or you can see it right away to subtract those two pieces, that's okay too. But there we go. Number 3, we want to find the area underneath the graph of f of x. F of x is defined as a piecewise function here, which means we're going to have two different pieces to it. So we'll have two different integrals. I would say the first integral goes from 0 to 10 of x squared dx. And the second one is from 10 to 15 of 100 dx. I'm going to use the fundamental theorem of calculus to solve these. So this becomes x to the third over 3 between 0 and 10. This is 100x between 10 and 15. So this would be 10 to the third over 3 minus 0. Plus this is 100 times 15 minus 100 times 10. I'm going to go this way. So I've got 1000 over 3. And then it'd be 100 times 5, so 500. Okay. There you go. There's your answer. So 1000 divided by 3 is 333.3 repeating. You could add them together if you wanted to. Number 3, all done. Average value. This is a definition. We should definitely have it memorized. It's not terrible. It's 1 over b minus a, the integral from a to b, f of x dx. This y bar or F bar means average value, and this is the formula that we're going to use. So y bar is 1 over 2 minus 0, the integral from 0 to 2 of x cubed d cubed, not d cubed dx. So this is 1 over 2, antiderivative is x to the 4th over 4, between 0 and 2. And again, just keep going with your fundamental theorem of calculus. You're a pro at that now. 2 to the 4th over 4 minus 0 over 4. 2 to the 4th is 16 over 4. So that's 4 minus 0. So our final answer is 2. So your average value, and I can show you what this looks like as well. We can do a picture of this. So x cubed, there's my cubic function. Here's 2, over here is 0. So here's my shaded area. All this. The average value, you're coming up with the average y value. It's kind of like a weighted average. It's not necessarily in the middle of those x coordinates. Maybe it's somewhere over here. By the way, this ordered pair would be 2, 8. So mine is definitely not drawn to scale, but y bar is the y value. So I'm saying that this is a 2. Average value. B minus A would be the width, this B minus A. And if I know that this is the area, right, that's area under a curve, I could say that the area of this blue rectangle matches the area of the red shaded region under the curve, if you want a picture of what's going on. All right, keep going here. Displacement and total distance. So when we integrate velocity, we can get that position and some kind of change in position. If we just integrate velocity as is, this is your net displacement. So you could start in my classroom, walk to the restroom, and come back. Your net displacement would be 0. If you look at total distance traveled, you'd start in my classroom, walk to the restroom, however many feet that is, walk back however many feet that is again, and that's your total distance traveled. So this one would have a net displacement of 0, start and stop in the same spot. This one has a longer distance traveled. So example 5, let's try this one. An object in rectilinear motion is moving along a horizontal line with a velocity of 3t squared minus 18t plus 15 in meters per minute for a time between 0 and 6 minutes. Find the net displacement from 0 to 6 and interpret the results of the problem. I know that's your least favorite. So you're going to set up the integral between 0 and 6. It is of the velocity. So inside, I'm going to use 3t squared minus 18t plus 15. Fundamental theorem of calculus. This is t cubed minus 9t squared plus 15t between 0 and 6. So 6 cubed minus 9 times 6 squared plus 15 times 6. And luckily, everything else is a 0 after that. I don't have a calculator right next to me, so whatever that number turns out to be, but this would be the displacement. So if we interpret the result meters per minute, we're going to drop the per minute. So this would be however many meters. You can use the word displacement if you wanted to, meters displaced. And you make sure you use the time. So between t equals 0 and t equals 6 minutes. Because if you did this problem again between 1 and 7, or between 6 and 12, or between 12 and 18, you'd have a different answer. So you need to make sure that you are indicating at what time interval you calculated this. All right, part B, find the total distance traveled by the object from 0 to t and interpret the result. So total distance traveled, this is where you need the absolute value. Now, it's not absolute value of the final answer. You're not going to tell me, oh, it's already positive and we're good to go. Your absolute value actually needs to go inside of the problem. It needs to go right here. And that will change things. So when I look at this, if I look at t squared minus 18t plus 15, I know it's a parabola. I could factor a 3 out of that. This is t squared minus 6t plus 5. I know that this factors further, t minus 1 and t minus 5. So t is equal to 1 and 5. That's helpful to me because I know that those are the zeros or the x-intercepts. So I have a parabola. Here's a 1. Here's a 5. It opens up. And over here is a 6. So when I'm looking at this picture, for total distance traveled, we have some positive distance, and we have some negative distance, and we have some positive distance. When I look at the next piece here, when I look at the absolute value, what that's going to do is take this part that's down here underneath the x-axis, and it's going to flip it up above. So now it counts as a positive area, and we're going to add that in there. So 2 ways you could do this. If you do not have access to your calculator, you need to know where it crosses the x-axis. You're going to have 3 integrals. You're going to go from 0 to 1, a v of t dt. Then you'll go from 1 to 5, a v of t dt. And then you'll go from 5 to 6, a v of t dt. Now, the nice thing is you've already calculated the antiderivative, so you just have to put the values in. Kind of annoying, but you can do it. The other thing you could do, well, and actually, by the way, this one's going to be positive, this one's a negative number, and this one's a positive. So you have to take the absolute value of this negative piece. The other thing you can do is that math 9. If it's a question where you're allowed to use your calculator, you can math 9. And then if you go underneath number, I'm pretty sure it's number 1, but I always doubt myself, it says absolute value. You can get the absolute value inside of that. So when you go to use math 9, it'll look like this. Here's your D in a box, and it will pop in some absolute value brackets for you and another box inside. So you can type in the problem that 3t squared minus 18t plus 15. You can put that inside and get your answer. So there you go. Again, I don't have my calculator next to me, but I have no doubt that you can figure out what those two things are. And then this is just a graphic of a reminder how we can relate position, velocity, and acceleration. We have derivative form, we have integral form, graphs of distance, velocity, and acceleration. So maybe that will help you out a little bit along the way. Keep working on these. Let me know if you have questions.